There you are. Welcome to Earth Science. How's everybody? So, cyclonic weather. What we're going to do in this lab is a three-part lab, and we're going to look at the three basic types of cyclones, which are all low-pressure systems. Remember, this is where the action is. Highest, maybe to a meteorologist, could be argued to be a little bit more boring. We can't do a lab on it. It's sunny out. It's nice. There's not much to analyze there. But because of everything that's going on with the lows, how they pull in air, they tend to be where the action is for meteorology. So these three low pressure systems that we'll study in this lab, I'll spin which way here in the Northern Hemisphere. You could use your cheat sheets and look it up. I could also just tell you. They go counterclockwise around the low. So they pull the air in and then it gets spun counterclockwise around it thanks to the Coriolis effect. So through the lab, we're going to look at hurricanes. That's first. That'll be in this video. Tornadoes. That'll be next. And mid-latitude cyclones. Which doesn't, that part of the lab's fairly quick. If you start to get intimidated and say, man, this thing's going to last forever, yes, it's a little bit long. But I think it's front loaded with the harder stuff, the slower stuff at the beginning, and then it should speed up as you go through it. So don't panic. Keep focused. You'll do great. So hurricanes, starting there. What would be the biggest, most dangerous of these systems, right? They form at about 10 degrees. Sorry, doing it slower. 10 degrees north, about 20 degrees north latitude. All right. Not so much due to the spinning in the Coriolis, not so much closer to the equator. And they need warm water. They strengthen due to warm water. We're going to say that in a minute here. So you can't form them too much further north of that either. That tends to be the belt where they start. They strengthen, there you go, when the pressure drops due to evaporating warm water. That's what is going to continue to strengthen and continue to build the hurricane. It's like a positive feedback loop. As the more water evaporates, the pressure drops, the winds get stronger, which means more water evaporates, which means the pressure drops further, which means the winds get stronger, and so on and so on and so on. That perpetuates it. But therefore, they weaken when they hit land or cold water. Intense, those are going to come up on questions later. So yeah, because you're going to follow the path of a hurricane, and then you're going to see where is it getting stronger and stronger and stronger, and then where is it getting weaker and weaker and weaker. Hint, hint, there's your answer. Physics says, and this I'm going to say that here instead of getting into like the complicated end of why this really happens, but because of the way that they spin and the way that our planet spins and what's going on, they'd be happy. They would like to move straight north, right? So if they form somewhere between 10 and 20, say underneath my cursor right here, they would like to go straight towards the pole. However, their path is influenced by the wind belts. And if you remember this Earth Science reference table, we've been playing with it a lot lately. What that will do is as it goes north, it's going to be stuck in this wind belt with northeast winds. And again, that means it's coming out of the northeast, right? So as it goes up this way, how's it going to get shoved by the wind belts? Then it gets to 30 and it enters this wind belt with southwesterly winds. So what happens there? So that's going to be your job. So what you're going to do on the map right here, draw a colored line right at 30 degrees north. And I'm doing that because of that. I'm not just making up, hey, let's do 30. 30 is that area where one belt is separated from the other. So draw a colored line, use your line tool. 30 degrees north is right here, and go right across. Then you're going to plot the paths of these two hurricanes, and it's your lucky day because this lab was getting big. I did one for you already. So I did that one, which was Irene. I did the bigger one too. So I plotted all of those by latitude and longitude. And then you're going to do Katrina. And I even did the first two spots on that just to like say, hey, let's get going. So if you're saying, Finn, I don't know how to do this, I took that latitude and that longitude and I put a dot. And then I took that latitude and that longitude and I put a dot. So you're going to do that, dot, 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 keep it going. And, It'll look just like this, only maybe with red dots. And then we'll see what happens when it gets to this line at 30, which again is this line. That's where the wind belts change. Sound good? So check that out. Then you'll analyze some of these, explaining why it's the case, like what happened, what's the case. Then let's talk about pressure and wind speed by plotting a graph here of what does the pressure do throughout the development of the storm, and what does the wind speed do throughout the development of the storm. So these dates down here, every other line, are the exact dates for Hurricane Katrina that are plotted up here. So at that date and time, then that date and time, what you're going to do is plot the wind speed, how fast is the wind going, and then you're going to plot the pressure. And I think it's easier probably to do the whole pressure one first and then do the whole wind speed second, or vice versa, whatever. If you're trying to do both, it might get a little frustrating. But again, I did the first two for you. So if you're saying, I don't know how to do this, at that date and time, the air pressure was 1007. One moment. So I did the first two for you right there. The pressure was 1007 and the wind speed was 20 something, right? Whoops, sorry. Wind speed was 26, pressure was 1007. Then it went to 1006 and 30. So just go ahead and plot those same values. They're there. And I did those two for you, and then just work your way down the line. Then it's just comparing. What does the pressure do? And as that changes, what does the wind speed do? Identify the relationship. We're all doing okay here. Tell me, how does that affect that? All right, then that's pretty much going to be the end of me talking. You got a couple questions here to look at that stuff, and you've got a regions question here, which is off of a map that they did in the region. So there's all the data, and you can do the questions right through here, and you'll do a great job. All right, part 2 tornado will be on the next video. Good luck, everybody. Keep it up.